All right, here's our notes for this last section in our chapter 6 and our learning about exponential and log functions. So we're really just looking at this very last learning target today. I can write exponential functions and use technology to find models. And I'm going to give you and have you, in your handout, you have some information of how you can use Desmos to help you do that. So here we're doing section 6.7, and that's really what we're looking at in this sheet of paper. So you'll just need a pen today. So first, our first question that we're going to answer is what type of function models this data, and how do you know? So we always want to look first to make sure that our x values are increasing at a constant rate. So here I see that my x values are increasing by 10 every single time. So since that is constant, then I can follow my next steps to see what kind of function this is. Well, here I see I'm subtracting 3 every time. Since I'm doing the same thing and I'm subtracting, here's where I either add or subtract the same thing. That tells me it's a linear function. So that would mean that in Desmos, I could use my linear regression. Okay, so let's look at the second example here. So again, my x values are increasing or decreasing. They're doing the same at the same rate. So here I see I am multiplying or dividing. So right, I'm multiplying by 1/3. Even though it's getting smaller, I'm dividing by the same thing. So since I'm multiplying or dividing by the same thing, this would be an exponential function. Okay, and I'm going to give myself a couple little notes over here, right? This means I multiply by the same thing. And that linear was where I added the same thing. Okay, so we have one more example here, and let's look and see what happens here. So again, my x's are increasing at a constant rate, so that's the same thing, right? I'm increasing by 2 every time. So now let's look at our y values. Well, I see I go from 2 to 0 to 2 to 8 to 18, so I'm not adding the same thing, and I'm not multiplying by the same thing. So let's see what we're doing here. So since I'm increasing, here I go down 2. I go up 2, here I go up 6, I go up 10, and on and on. Well, let's look at our second difference. That's what we're going to look at here. So this would be our first difference, is just what is happening to my y's. So the next thing we look at is our second differences. Let me go ahead and get a black pen. So from here to here, I see I go up by 4, I go up by 4, I go up by 4. So since these second differences are the same, this would be a quadratic equation. Okay, so it's really kind of handy to know which one of these 3 to use so that you can then use your technology, use Desmos to help you kind of get that and figure it out. Okay, so that's how we can determine and classify our data of what type of function it is. So the next thing we're going to be looking at is we're going to be writing an exponential function if all we're given is 2 points. So sometimes we can use technology and sometimes we're given the equation, but what happens if we don't have the equation but we have a couple of the points that we're given? So if we're given something like this where we're just given 2 of the points, we can go ahead and still write that equation. So the first step we do is we have to write out 2 different kind of equations using this model, or y equals ab to the x, because here I have some x's and some y's. So let's go ahead and write one. So we end up with 6 equals a b to the 1, and we have 54 equals a times b cubed. Well, here let's look at this top one. This one's fairly simple because b to the 1 is just b. So what if I was to solve for that a value right here? So I end up that a is equal to 6 divided by b. Well, now that I've solved for a, I can plug that in to the second equation. So 54 equals the a value, which was 6 over b times b to the 3rd. Well, now I see I just have some different exponents, and let's go ahead and simplify that. So I know that I have 1 in the denominator and 3 in the numerator. Okay, equals 6b cubed over b. So when following my properties of exponents, if I'm dividing, I go ahead and I subtract them. So I end up with 54 equals 6b squared. Well, now I can just get that b by itself, so I divide both sides by 6. and I continue to simplify. And here I know that 54 divided by 6 is 9 equals b squared. Well, to undo that squared, I go ahead and take the square root of both sides. So b equals my 3. So the reason here that I only took that positive 3 is because we were talking when we're dealing with these exponential functions, our b is always going to be a positive value. Because remember, whenever I take the square root of something, it's the positive and negative roots. But here I only want the positive value. So now that I have b, I can actually finally go back and rewrite my final equation. And to write that final equation, I take this b and I plug it back in here to find my a value, because that's the most simple place where it was. So a now equals 6 divided by 3, which equals 2. So now I have both my a and my b, so I end up with y equals my a was 2 times 3 to the x. Okay, so now I have my final equation written from just these 2 points. So you always just come up with your 2 equations, solve for a in one of them, and then your b's can kind of go from there. Okay, so the last thing we're going to be doing is using technology. And here we're really going to be using Desmos. And I gave you your equations that we're really going to be using in your homework. So the first step, remember, when we're using our regression feature in Desmos, is we enter our data into a table. And then from there, in the next line, we determine which one we're going to be using. Are we using exponential? Are we using logarithmic? Are we using quadratic? Are we using linear? So following these kind of steps can help you determine which function to use. So then once you do that, you're going to go ahead and type them in exactly as they're written here. And you will be given your a and b values because Desmos is going to do that regression for you. So now the easiest way to make this kind of stick in your notebook is I'm just going to fold up this bottom part just a little bit and then glue this whole piece in so it actually just fits on the page without overhang, and so I can just refer back to it often whenever I get stuck, or if I'm like, I don't remember the equation, I type into Desmos to help me find the equations. So that will be always there for you as well. Okay, so now we've worked through and taken notes and learned everything about our exponential and logarithmic functions. So especially for this section, you are gonna need to be using Desmos because you're gonna be asked, here's some data, here's these lines, now write my regression. Okay, so make sure you can follow these kind of steps to see which type of function am I dealing with, and then use our regression in Desmos to get there. Okay, so now's that time when you're going to go and work on your homework, and let me know whenever you get stuck on anything.